Beyond the orbit of Neptune, the solar system dissolves into a freezing, pitch-black vacuum. But drifting through this absolute darkness are a handful of silent, human-made messengers. In 1977, NASA launched the twin Voyager probes. Equipped with massive parabolic antennas and instrument booms, they were designed to survey the outer gas giants. Nearly 3 decades later, in 2006, they were followed by New Horizons, a spacecraft wrapped in gold foil and packed with modern electronics built to explore the distant Kuiper Belt. Despite the massive leap in technology between the 1970s and the 2000s, these machines share a single inescapable physics problem. They are moving too fast to ever turn around. There is no return trajectory. By pushing these physical objects past the sun's gravitational grip, we crossed a permanent threshold. Humanity is now an interstellar presence. The Voyagers were originally built to take advantage of a rare planetary alignment, a grand tour that allowed a single spacecraft to visit multiple outer worlds in one continuous sequence. When Voyager 1 arrived at Jupiter, it captured the violent dynamics of the planet's atmosphere in breathtaking detail, revealing swirling cloud bands and the immense churning storm of the Great Red Spot. It then swung past Saturn, beaming back high-resolution images that mapped the intricate structure of its vast, shadowed rings. Fast forward to 2015, and New Horizons finally reached its primary target, Pluto. It revealed a geologically complex world, dominated by a massive, heart-shaped glacier of nitrogen ice called Sputnik Planitia. In a matter of decades, these probes turned blurry, pixelated points of light into mapped, dynamic worlds with active geology and complex weather. Because New Horizons launched on modern rockets, it left Earth as the fastest spacecraft ever flown. Yet it will never catch up to Voyager 1, which had a 30-year head start. This is a map of New Horizons' trajectory. To reach Pluto, it relied on a single gravity assist at Jupiter, stealing a small fraction of the planet's orbital energy to boost its speed outward. Now look at Voyager 1's path. Thanks to that rare planetary alignment, it was able to chain its gravity assists together, slingshotting past both Jupiter and Saturn to steal massive amounts of momentum. Those compounded boosts give Voyager 1 an inescapable lead. It is escaping the solar system at 17 kilometers per second, while New Horizons is moving at just 13. Out in the deep solar system, the sophistication of your launch vehicle matters less than the geometry of the planets you pass along the way. Raw orbital mechanics dictate the winner. In 2012, Voyager 1 crossed the heliopause. This is the boundary where the protective bubble of solar wind generated by the sun gives way to the ambient pressure of the interstellar medium. At this distance, it takes light nearly a full day to travel from Earth to the probe. A simple command sent today won't receive a reply until the day after tomorrow. With each passing year, the plutonium power supplies on these probes decay slightly more. To keep core systems running, engineers are forced to shut down scientific instruments one by one. Eventually, the power will drop too low to sustain any active science. The final instrument will switch off, and the probes will permanently stop transmitting data. When that radio silence begins, their role as explorers will end. They will drift through the absolute zero of deep space as passive, inert monuments. Knowing this inevitable fate, the engineers who built Voyager bolted a gold-plated copper disc to the outside of the chassis before launch. Curated by a special committee led by the planetary scientist Carl Sagan, this golden record contains 115 images, sounds of the natural world, greetings in 55 languages, and a mix of global music. The distances between stars are so impossibly vast that even traveling at 17 kilometers per second, it will be 40,000 years before it approaches another planetary system. Protected by the vacuum of space, these records will remain intact for billions of years. Long after our sun has exhausted its fuel and the Earth is entirely unrecognizable, they will still be moving. Their grand mission to map the outer planets was completed decades ago. But for the rest of cosmic time, Voyager and New Horizons will carry a small, indestructible fragment of who we were into a future we will never see.